P-values are the probability computed assuming that null hypothesis is true, that the observed outcome would take a value extreme or more than that actually observed.
This basically means that the z-scores are a special number that find how many standard deviations away a certain relevant number is from the mean. Once the z-score is found, it can be used to find the probability of that number, or less, happening.
Our example is 10.44 on page 582. Here are the IQ test scores of 31 7th grade girls in a Midwest school district: 114, 100, 104, 89, 102, 91, 114, 114, 103, 105, 108, 130, 120, 132, 111, 128, 118, 119, 86, 72, 111, 103, 74, 112, 107, 103, 98, 96, 112, 112, and 93. We are doing B, which relates to the p-values. Is there significant evidence at the 5% level that the mean IQ score in the population differs from 100? Give appropriate statistical evidence to support your conclusion.
We first have to construct a density curve of the distribution by finding the mean and standard deviation. To find the mean, we add up all of the numbers and divide them by how many there are. The mean is about 105.84. The standard deviation is found by this equation, where n is the number of data, x is one of the data, and x bar is the sample mean. The standard deviation is 14.27. This is the density curve for the data set. Second, we need to follow the inference toolbox. Step 1. State the null and alternate hypothesis. The null is x equals 100 and the alternate is x does not equal 100. Step 2. Determine the proper method and see if we can proceed by checking the conditions. We want to do a two-sided z-test, and so therefore we can proceed because the sample data comes from an SRS and the population of 7th grade girls is larger than 10 times the sample size. Step 3. Continue with the operations by finding the z-score, which is found by subtracting the sample mean by the population mean, divided by the population standard deviation, which is divided by the square root of the number of data. By using Table A, we find that the z-star for 2.17 is 0.9971. We want to see if the mean does not equal 100, so this is a two-sided z-test, which means we have to do 2 times 1 minus 0.9971, which equals 0.0058, which we can now compare to the 0.05 level. Step 4. Interpret the results. Since 0.0058 is less than 0.05 or 0.01, we can reject the null hypothesis in favor for the alternate hypothesis. This means that there is sufficient evidence to suggest that the mean IQ score is different from the proposed mean of 100.